Hi, I'm going to teach you how to fetch data from an SSAS cube using PySpark and create an KMeans model and visualize the results of the KMeans clustering by Pyspark MLib. First block. This part of code imported necessary libraries from for running a PySpark KMeans clustering algorithm and pass. Pass is a list in Python that contains the directories where the interpreter looks for the Python models. And find a spark. Find a spark initiates is used to initialize PySpark on the local machine, and PySpark matplotlib.pyplot, spark-sgen, vector assembler, standard scalar, KMeans, and clustering evaluator all PySpark libraries used for machine learning tasks such as clustering. Okay, I run it. And next block. Okay. What's the spark-sgen? Spark-sgen is the entry point to programming Spark with the dataset and data from API. And builder method. The builder method is used to create an instance from the spark-sgen.builder and config. Oh, sorry. Before that, what's the app name? It's application name. Config. The config method is used to set configuration options for the spark-sgen. Okay, and what is the driver memory, executor memory, and executor cores? Driver memory is amount of the memory to use for driver process, and executor memory is amount of memory to use per executor process, and executor cores number of the cores to use per executor process. Okay, and we go next block. And here, and okay. To the fetch data from the from SSAS by PySpark, we need these libraries. Okay, these libraries. MSOLAB or AMD's 64 or MSOLAB X86. Yes, we need these libraries that can be downloaded from the Microsoft website. I have put this address in the description. Okay, back here. The client libraries are necessary for client application and tools to connect to analysis service. Microsoft client application like Power BI, Desktop, Excel, SQL Server Management Studio, and Analysis Service Project extension for Visual Studio and others. And here, what's the append? Pass that append. Append is path to list of directories in which Python search for models. And this library. PyADOMD is a Python library that provides that Pythonic approach to query SSAS data models. It's typically used in data science and pandas application. Okay, and next block. Connection string. Build a connection string. Provider is MSOLAB. Its server name, okay, and it's related to authentication. And catalog name is your cube name, okay. And Next, it's query string. We must write mdx query, this one, for fetch data from the SSAS cube here, and select measure order quantity and measure the sales amount and columns. This specify the measure to retrieve on the column axis. In this case, it's the order quantity and sale amounts measures. And here, non-empty products category and product subcategory and products name. This specifies the hierarchy to retrieve on the row axis. In this case, it's category, subcategory, and product hierarchies. And here, in this case, it's works with the adventures work cube. Back to Jupyter, and this part of code is used to execute an mdx query against an unsafe database and create a PySpark data frame from the result. This creates a connection to the unserviced database using the connection string defined in the previous code, and they execute an mdx query using the cursor object returned by the connection. The query is defined in the variable query string here. This creates a PySpark data frame from the result of the query. And here, the type function returns the type of an object in Python. In this case, it's returned the type of the dataset object, which is a PySpark data frame. Okay, and next block. Okay, the print schema method is PySpark data frame method that prints the schema of the data frame of the data frame to the console. The schema describes the structure of the data frame, including the name and data types of columns. Here, name and data type. Okay, next block. Okay, next block. The with column method is PySpark data frame method that returns a new data frame with a new or updated column. In this case, it returns a new data frame with the sales amount columns cast to a line data type here and here. And okay, I run print schema again, and you can see change the cell amount data type from the double to line dataset. That's show. The show method is a PySpark data frame method that displays the contents of the data frame in a tabular format. By default, it's display the first 20 rows of the data frame. Okay, you can see here 2 rows, and this part of code is used to transform the PySpark data frame name dataset by combining the order quantity and sale amount columns in a single feature column. I explain about this block. The vector assembler here function is a PySpark ML function that combines multiple columns into a single vector column. In this case, it's used to combine the order quantity and cell among columns into a single features column named features. You can see here this one and this one combined together in features column. And input call. Input calls parameter specify the name of the columns to combine, and here output calls parameter specify the name of the new vector column. Okay, and here transform. The transform method is a PySpark data frame method that applies the transformations to the data frame and returns a new data frame. In this case, it applies the transformations defined by vector assembler function to data frame and returns a new data frame with an additional features column. Okay. This part of code is used to scale the features column of the PySpark data frame named data_df. What is the standard scaler here? The standard scaler function is a PySpark ML function that scales the values of vector columns to have a zero mean and unit standard deviations. In this case, it's used to scale the features column of the data_df data frame. And what is the input calls this method? The input calls parameter specify the name of the vector column to scale, and the output call here, and the output calls parameter specify the name of the new scale vector column, and here scalar model. Okay, I want to talk about fit method. The fit method is a PySpark ML method that fits a transform to a data frame and returns the transformer model. In this case, it fits the standard scalar function to the data_df data frame and returns a scalar model. Okay, here, and we talk about the transform here. It's last line. The transform method is a PySpark data frame method that applies transformations to the data frame and returns a new data frame. In this case, it applies the transformations defined by the scalar model to the data_df data frame here, data frame, and returns a new data frame with an additional scale features. Okay, here, and you can see a scaled features column here. Next block, and this part of code is used to compute the within set sum of the squared errors W/SSE. And silhouette score for different values of k in KMeans clustering. Okay, and W/SSE or WSSSE SSE is a list stores the W/SSS values for different values of k. What is SSE? WSSE stands for within set sum of the scored errors. It is a measure of the quality of the clustering algorithms, such as K-means clustering. The WSSS measures the sum of the scored distance between each point and its centroid in a cluster, and the goal of the K-means clustering is minimize the WSSE, which means that we want the points within each cluster to be as close to each other as possible. Okay, here, this line. Okay. This part of code is used to create an instance of the cluster evaluator function with the specific parameters. And here, this method, clustering evaluator. Clustering evaluator function is a PySpark ML function that evaluates the quality of a clustering model. In this case, it's used to evaluate the silhouette score of the K-means clustering model. And the prediction parameter. The prediction call parameter specifies the name of the column containing the predicted cluster labels. The feature call parameter specifies the name of the column containing the feature vectors here. And metric name. The metric name parameter specifies the name of the evaluation metric to use. In this case, it's set the silhouette. What is the silhouette? Here. Okay, what is the silhouette? The silhouette score is a metric used to evaluate the quality of clustering algorithms, such as K-means clustering. It's measured how similar an object is to its own cluster compared to other clusters. The score range from -1 to +1, where a score of the 1 indicates that the object is well matched to its own cluster and poorly matched to neighboring cluster. And a score near 0 indicates overlapping cluster with the samples were close to decision boundary of the neighboring cluster. A negative score indicates that the object may be assigned to a wrong cluster. Okay. And what is this? Okay. In K-means clustering, the score Euclidean, the distance is used to measure the distance between a point and its assigned cluster centroid. The goal of the K-means clustering is to minimize the sum of the scored Euclidean distance between each point and its assigned cluster centroid. Okay. And for this loop. Okay, and this part of using the PySpark library for perform K-means clustering a dataset. This code is iterating over the range of the value k number of the clustering from the 2 to 7. Okay, and 2 to 7, sorry, 8, and for each values of a k is create a K-means model with a specified number of the cluster and fits it to the data. It transforms the data using the fitting model and calculate the silhouette score for the clustering result using an evaluator. Silhouette score is measured of how well each data point fits into its assigned cluster. Finally, it appends the score to list of the scores and prints it out. Okay, here This line set up a loop that will iterate over the of the chain from 2 to 7. Okay, and next line. This line creates a K-means model with a specified number of the cluster I here. Cluster and feature column column feature a scale feature and this line fits the K-means model to the data and output. This line transforms the data using the fitted model, and here a score. Okay, this line calculates the silhouette score for the clustering result using an evaluator. Okay, and SSAS. Okay, and this line appends the score to a list of the scores. And finally, the line prints out the silhouette score for each value of k. Okay, I run it. Okay, you can see silhouette scores here. Okay. This part of code is plotting the SSAS values against the number of the clusters k on the x-axis. Okay, this line plots the SSAS values against the range of the values from the k from 2 to 6. Okay, and I run it from 1 to 6. Okay, and next line, set x-axis label. Yeah, and this line sets for the label for the x-axis, and this line sets the label for the y-axis, and this line set the title for the plot, and this adds grid, and this line shows the plot. Okay. This part of code creating K-means model with the specified number of the clusters here. Cluster and feature columns, scale features, and the fits K-means with to the data, and this line the K-means model to the data. Yeah. Okay, data and underscore df, and final line of this block assigning the data points to clusters. And the next block here, K-means underscore fit dot transfer. It's a function in PySpark is used to transform the input data frame using the trained K-means model, and output of this function is new data frame with the same column as input data frame, and here and plus features which contains the distance of the each points of the century. Okay, and here we talk about the evaluator. Okay, evaluator .evaluate function is used to evaluate the quality of the clustering model by computing within a set of the squared errors SSAS. Okay, and here okay, and fine, and this my snip code. you are using two functions of the evaluate and quality of the KMeans clustering model. The KMeans clustering model function is a transform the input data. Okay, sorry. Okay, the first block of code, you are using these two functions to evaluate and evaluate the quality of your KMeans cluster model. The KMeans the KMeans underscore fit transfer data. Okay, this here. Here is transforming your input data from data underscore df using the train KMeans model. Okay, and the resulting data frame is the pass to the evaluator that evaluate function, which computes the SSAS for this output frame. Finally, the SSAS value is printing using the print function. Okay, you can see SSAS value. And next line. Sorry, next block. First line of this block, converting to pandas data frame. This part of code used to visualize the result of a KMeans clustering algorithm and apply to PySpark data frame. Okay, and the first line code convert the PySpark data frame cluster underscore data to a pandas data frame using the to pandas function. The resulting pandas data frame is stored in the variable cluster underscore data underscore pd. And yeah, you can see here the final result. And here, and next line, the next line of code use the scatter function from the matplotlib library to create a scatter plot of the order quantity here. Okay, order quantity and cell amount columns from the pandas data frame. The color of each point in the scatter plot is determined by the cluster column of pandas data frame using the C parameters. Here. Okay, C parameters. The CMap parameter specifies the color of the CMap to use for the plot. And here we define set X label name, Y label name, title, and color ball, and show the plot. Okay. Yes. We have five clusters. 1, 2, 3, 4, 5. Okay. And finally, spark.stop. What is that? The spark.stop function is used to stop the Spark session and release all resources used by it. This function should be called at the end of your Pyspark application to ensure that all resources are properly released. Thank you for your watching.